Every year, more than 2 million tons of meat are produced without coming from livestock farms, yet they nearly perfectly replicate the aroma, flavor, and even the charred reaction of real meat. This is plant-based meat, a rapidly emerging industry that seeks to recreate meat using only plants. That journey begins in vast soybean fields stretching across thousands of hectares, where tiny beans are harvested like strategic resources, then transported directly to factories within hours. Inside, heat, pressure, and mechanical force restructure natural plant proteins into fibers that behave like real muscle tissue. The result, patties that sizzle on the grill, release savory aromas, and even change color, appearing to bleed when exposed to heat, convincing even longtime meat lovers. Today, join Agriculture Insight as we unpack the processes behind plant-based meat to discover how this so-called meat of the future is truly made, and whether it really holds the key to humanity and the planet. Plant-based meat officially broke into popular culture in 2019, when Beyond Meat and Impossible Foods simultaneously pushed plant-based burgers beyond the vegetarian niche, placing them in direct competition with beef on supermarket shelves and in major fast food chains. In a short time, what had been a niche alternative was shaped into an entirely new industry. Beyond Meat targeted consumers who still enjoy eating meat, with burgers made from pea protein, promising to reduce dependence on animal farming without forcing people to change their eating habits. Meanwhile, Impossible Foods chose a faster and broader path, partnering with Burger King. The Impossible Whopper, made with soy protein, generated over $100 million in just 4 months, becoming one of the most successful product launches in the history of American fast food. But the excitement did not last long. Shortly after Beyond Meat reached a peak market capitalization of nearly $14 billion, the U.S. plant-based meat market began to stall and then decline. Consumers shifted from curiosity to skepticism. Despite having protein levels comparable to beef, plant-based meat is a highly processed product, often containing high sodium levels and an ever-growing list of ingredients. The paradox lies here. In supermarkets, a single Beyond Burger still costs more than $2, nearly twice the price of a standard frozen beef burger. So what exactly in the production process has driven the cost of plant-based meat to this level? And who is really paying that price? For technology, for the environment, or for consumer expectations themselves? The journey of plant-based meat, often described as a solution to reduce the environmental burden on the planet, actually begins with something remarkably small: soybeans. From late September through November, soybean fields stretching across the American Midwest enter peak harvest season. More than 70% of today's plant-based meat products rely on soybeans, not by chance, but because of their exceptional water-holding capacity and fiber-binding properties, which create the closest chew and fibrous pull to real meat. To preserve these characteristics, soybeans must be harvested at a precise biological window. The plant has dried, while the beans retain approximately 15% moisture. Harvest too early, and the proteins are not yet stable. Harvest too late, and the beans crack easily, losing their ability to bind and form structure. When harvesting begins, headers nearly 12 meters wide are lowered close to the ground to collect pods growing low near the base of the plant, where nearly all yield is concentrated. Inside the machine, threshing drums, sieve systems, and air fans separate the pods while keeping the beans intact. Meanwhile, dry stems and leaves are returned to the field, forming a biological mulch layer that protects the rich mollisol soils beneath. Each hectare can yield around 4 tons of soybeans, but for the plant protein industry, only batches with at least 95% intact beans are accepted. Cracked beans, though still edible, have lost their ability to form fibers and gels, making them unsuitable for replicating the structure of real muscle tissue. These stringent requirements mean that the plant protein supply chain cannot rely on a single crop alone. To create a light-colored protein base with a neutral aroma and lower allergenic potential, the industry also turns to peas. Unlike soybeans, peas used for protein extraction are harvested while the plants are still green, when the seeds have reached full size but before starch conversion begins. This requires an entirely different type of machinery, the pea viner, a machine designed to separate fresh peas rather than cut and thresh dried crops like conventional harvesters. At the front, gathering reels pull in the entire plant and feed it directly into the machine. An in-feed elevator lifts the full vines into the separation chamber, where high-speed but low-impact beaters open the pods, allowing the peas to fall free without being crushed. The material stream then passes through a rotating screening drum, continuously sorting between acceptable peas and remaining plant matter. Clean peas are transferred into a sealed onboard hopper, preventing contamination and minimizing mechanical damage during transport. Operating in a continuous cycle, each pea viner can process approximately 3 hectares per hour, supplying a steady stream of raw material to protein isolation facilities. From this moment onward, the quality of plant-based meat is already determined in the field, long before any downstream technology intervenes. The process begins by blending plant proteins with liquid fats. Isolated and dried legume proteins are fed into sealed mixing vessels, where they are combined with water, vegetable oils, and emulsifiers to recreate the fat content and water-holding capacity of meat. Within minutes, the proteins become fully hydrated, forming a moist, pliable mass. Under high torque, protein chains are forced to realign in the same direction, creating fibrous structures that produce the tear and chew associated with meat. Among them, soy protein provides more stable chewiness, while pea protein offers a milder aroma but a softer structure. However, texture alone is not enough. To generate aroma and flavor during cooking, leg hemoglobin, a heme source naturally found in legume root nodules, is fermented, filtered, and concentrated into a dark red solution, then added to the protein matrix. This compound triggers the Maillard reaction, producing savory aromas, umami flavor, and a brown seared crust when exposed to heat, while beet-derived pigments serve only to enhance the red color in the raw state. Once the meat matrix reaches sufficient plasticity and cohesion, the entire mixture is fed directly into an automated forming system. The soft mass is continuously extruded and precisely cut to preset dimensions, ensuring that every piece leaving the machine is identical in thickness and structure. Round shapes are used for burgers, as they fit perfectly with sandwich buns. Rectangular forms are chosen for sandwich patties and ready-to-eat meals, thanks to their ease of stacking and precise portion control on industrial production lines. Immediately afterward, each patty is automatically placed into trays, sealed, chilled, and packed into cartons. From this point on, plant-based meat becomes a fully standardized product, ready for global distribution by manufacturers in the United States and Europe. On a separate production line, raw plant-based meat is also fed into structure testing and compression forming systems. Pressure and compression forces are carefully calibrated to replicate the thickness, elasticity, and cooked state behavior of real beef burgers before packaging. Once taken off supermarket shelves, plant-based meat is cooked almost exactly like traditional ground meat, but in reality, it is far easier to control during cooking. Anyone can become a home cook with a single pack of plant-based meat pulled from the refrigerator. Because the proteins have already been processed and stabilized in the factory, the mixture shrinks less, retains moisture better, and does not require precise timing for rare or medium doneness. This makes it especially well suited for quick pan searing and burger forming. With just 2 to 3 minutes of direct contact with a hot pan, the patty rapidly develops a brown crust and familiar savory aroma, while the interior remains evenly moist. For many American households, this is a clear advantage. Pre-packaged plant-based meat delivers consistent results, even when the cook has limited time or experience. At a professional scale, this advantage becomes even more pronounced. In fast casual chains, modern burger restaurants, and experimental kitchens run by young chefs, plant-based meat is often treated as a neutral protein base, lightly seasoned, pan-seared, or pressed flat to fine-tune bite texture. Thanks to its uniform structure, each batch produces nearly identical size, doneness, and cooking time, allowing restaurants to operate smoothly even during peak hours. Notably, frozen plant-based meat typically has a shelf life of 6 to 9 months, giving restaurants far greater inventory flexibility and significantly reduced waste compared to fresh meat. We rarely stop to think about this, but the number of livestock animals now exceeds the human population by 4 times, and the total biomass of animals raised for meat is nearly 10 times greater than that of all wild mammals combined. From an environmental perspective, industrial livestock farming accounts for around 14% of global greenhouse gas emissions, roughly equal to or even slightly higher than the entire transportation sector. In other words, in terms of emissions, the piece of beef on your plate carries a greenhouse footprint comparable to that of a vast transportation system operating every day. Few people know that Chef Boyardee ravioli was born as a pivotal twist that helped spaghetti enter industrial-scale production. As urban populations surged, the pressure to feed sprawling metropolises increased, and the demand for durable, transportable food that still maintained quality became a standard from the 20th century onward. But unlike any traditional long spaghetti, Chef Boyardee conquered the mass market while taking a distinct approach. Using square pillow-shaped ravioli allowed the soft pasta to fully encase the meat and sauce, making each portion compact enough to fit in a can and easy to eat directly with just a spoon. To this day, billions of cans of Chef Boyardee are produced each year, carrying the smiling face of auteur Hector Boyardee, who personally oversaw the recipes and production process for nearly 20 years before passing the brand to American Home Foods. This journey began with a simple observation at his restaurant. The number of customers buying sauce to take home far exceeded those dining in, revealing a demand for flexible eating beyond the traditional dining table. And now, let's step into one of the most crucial starting points: the vast tomato fields stretching over hundreds of thousands of hectares, the indispensable foundation of every red sauce spaghetti. In Pennsylvania, the land Chef Boyardee chose for his sauce, the warm summers, long days, and marked day-night temperature swings create ideal conditions for tomatoes to accumulate high dry matter, retain a stable red color, and develop a rich flavor when concentrated into sauce. Starting in August, when the tomatoes ripen all at once, the entire field enters a massive harvesting cycle. Self-propelled harvesters move across the rows, with cutting blades set about 4 centimeters below the surface to collect entire tomato beds while preserving the topsoil. Immediately after cutting, vibrating conveyors lift the plants, fruit, and soil onto the machine. Vibrations at a fixed frequency cause the ripe tomatoes to detach naturally from their stems, while soil and biomass fall back to the field, returning organic matter and maintaining ground cover. The tomatoes are then continuously guided onto an elevating conveyor and dumped into trailing bins, all while the machine maintains a steady forward speed. Under flat field conditions, uniform ripeness, and dry weather, each machine can harvest up to 80 tons per hour, producing a consistent and abundant supply, transforming the tomatoes into the key foundation for the thick, durable, and uniform sauce in every can of Chef Boyardee ravioli. Beyond tomatoes, the pasta layer made from wheat forms the essential foundation that shapes the very first bite of every ravioli. It all begins with the autumn harvest in the Midwest, which produces over 400 million tons of hard red winter wheat annually, Chef Boyardee's primary source for creating pasta that's both firm and pliable enough to cradle the filling and sauce perfectly. Once the kernels have fully accumulated starch and protein, reaching the right hardness for industrial milling, they are harvested using 500 horsepower combine harvesters on large-scale fields. The cutter head feeds the entire wheat stalk into the machine, where an auger moves the biomass into the threshing chamber. Here, the threshing drum separates the grain from the chaff with carefully controlled force to minimize breakage. Lightweight straw and husks are returned to the fields, while the heavier kernels are funneled directly into the storage compartment. When the bin reaches capacity, the discharge spout swivels toward a parallel transport vehicle, allowing the grain to be dumped directly without interrupting the harvesting rhythm. From these fully loaded bins, the wheat is then sent to silos and milling plants across the Midwest, producing around 50 million tons of wheat annually in the U.S., creating a stable supply that supports the continuous production of millions of cans of Chef Boyardee ravioli. And now, we arrive at the Angus cattle farms, the starting point for the rich filling, the element that defines the sense of fullness from the very first bite. In the early stages of life, calves stay with their mothers on natural pastures, grazing on tender, easily digestible grass to develop a stable digestive system and a strong skeletal frame, laying the foundation for steady growth later on. When separated from their mothers, the herd moves into a semi-free-range system. Their main diet consists of dry hay, alfalfa, and trace minerals, which keeps the rumen functioning smoothly, stabilizes fermentation, minimizes metabolic fluctuations, and promotes fine muscle fiber development. During the finishing stage, as muscle growth slows to allow energy accumulation before slaughter, Angus cattle are supplemented with grains such as corn, barley, and soy, conditions that promote the signature marbling, helping the meat retain moisture and remain stable when ground. On average, a full growth cycle lasts about 18 months, with cattle reaching 550 to 650 kilograms, an optimal weight for both steaks and industrially ground meat. It's this consistency throughout the entire process that makes Angus the core choice for Chef Boyardee, the foundation for meat batches that withstand high heat cooking and pressure sterilization while keeping full flavor, distinct grain, and that genuine, satisfying texture even in a canned product. Leaving the fields, all the main ingredients officially enter the factory. Before the tomatoes oxidize, darken, and lose structure, the wheat absorbs moisture, reducing dough elasticity, or the meat begins to lose water and undergo protein changes, throwing the entire batch off its technical specifications. Within just 6 hours of harvest, all the tomatoes are brought directly to the factory's receiving area, passing through an automated sorting system to remove unripe, damaged, or contaminated fruit. The tomatoes are then high-pressure washed, coarsely crushed, and rapidly heated to deactivate enzymes, lock in their natural red color, and stabilize dry matter content, creating a uniform input for the sauce cooking process. The Chef Boyardee ravioli process begins in an industrial steel kettle with a capacity of about 1,500 gallons, where water, sugar, and concentrated tomatoes are heated and continuously stirred to create a uniform sauce base. Once the mixture reaches a steady, gentle simmer, basil, rosemary, paprika, and a proprietary blend of seasonings are added. Over the course of roughly 60 minutes, mechanical paddles maintain constant motion to control consistency, color, and aroma, standardizing the sauce base before it moves on to the next stage. In parallel with the sauce, freshly ground beef is received daily and transferred into large heated mixing kettles, combined with chopped carrots, dried onions, garlic, and seasonings. The heating process, accompanied by continuous stirring, ensures the meat breaks apart evenly, releases its natural juices, and absorbs the spices, producing a filling with controlled texture and moisture, ready for the forming stage. Meanwhile, in the pasta section, semolina is fed directly from the silos into heavy-duty cross-arm mixers, where water is added in precise proportions. During mixing, gluten develops, forming the structural framework for the pasta. After about 10 minutes, the dough is transferred to a vacuum mixing chamber to remove excess air, stabilize the structure, and minimize surface defects in the cans. Kneading continues until the dough reaches the desired consistency and elasticity. The finished dough is pressed into blocks and passed through a multi-roller sheeting system to create thin sheets of uniform thickness. At the ravioli forming machine, the beef filling is deposited from above, while 2 sheets of dough advance from opposite directions. A pair of molding rollers simultaneously press, cut, and seal, producing hundreds of square ravioli in a continuous cycle, ensuring consistent sealing and size. The ravioli strips then enter a blanching machine, where hot water quickly cooks the pasta and separates each piece. Immediately afterward, the product is transferred into a deep cold water bath for a shock cooling step. This helps set the shape and enhances mechanical strength before canning. Immediately afterward, the cooled ravioli enter a rotary portioning machine. As the table rotates, the product is evenly distributed and guided into dosing chambers, with approximately 14 pieces dropping precisely into each can before the conveyor moves them onward to the sauce filling stage. Open cans pass beneath the filling system, where hot tomato sauce is pumped directly from holding tanks at rates approaching 600 cans per minute. Once the standard fill level is reached, the cans are rapidly sealed at high speed, locking in structure before thermal processing. To ensure complete coverage, the cans pass through a continuous inversion and rotation system, undergoing more than 10 flipping cycles. This motion allows the sauce to flow into every gap and fully coat all pasta surfaces. The cans are then fed into a rotary pressure retort. Within this controlled pressurized environment, temperatures reach approximately 250 degrees Fahrenheit and are maintained for about 45 minutes. The combination of heat and continuous rotation completes the final cooking stage, while ensuring safe sterilization for long-term shelf stability. After exiting the retort, the cans are rapidly cooled on conveyor lines before moving into the labeling area, where they receive the iconic image of Hector Boyardee. At the end of the process, products are case-packed by batch and distributed to supermarket and convenience store networks across the United States. From this solid foundation, Chef Boyardee has expanded far beyond ravioli, creating mass-market hits such as beefaroni, spaghetti and meatballs, and lasagna, with total annual production sustained at over 300 million units. While formats and flavors may vary, they all operate around one clear philosophy: delivering a fast, filling, stable meal that's easy to rely on again and again. Behind every delicious sausage is a journey that begins with little pink piglets growing up on happy farms. But why is that? Here's an interesting fact. Happy pigs produce better quality meat, leading to the finest sausages. That's why many farms go the extra mile to ensure their four-legged VIPs live a luxurious life. Think of it as a five-star hotel for pigs. They enjoy clean, spacious barns, refreshing baths every day, well-balanced meals, and even get to relax while listening to Mozart. And believe it or not, after about 180 spa sessions, these once tiny piglets, weighing just over 1 kilogram, grow into massive giants, tipping the scales at 110 to 130 kilograms. To sustain the breed, only the most elite pigs are carefully selected to participate in the modern breeding process. With the help of technology, from selective breeding to artificial insemination, a new generation of strong, healthy piglets is born. When the golden moment arrives, the pigs are ready to leave the farm and move on to their next destination, the processing plant, where their journey takes a new turn. Before hitting the road, pigs are given a light fasting period of about 12 to 24 hours, not to lose weight, but to ensure a smoother journey. Modern livestock trucks are also well designed, featuring multiple levels and partitioned sections to prevent overcrowding and jostling. Plus, they come equipped with ventilation and automatic temperature control systems, ensuring a cool, stress-free ride for their four-legged passengers. Everything is carefully arranged to transport happy pigs to the processing plant, where they'll soon take part in a little culinary magic, transforming into delicious sausages. After a long journey, the pigs finally arrive at the processing plant. The first and most crucial step is to let them rest in a clean, well-ventilated area equipped with mist sprayers and air circulation systems. This helps reduce stress, stabilize their heart rate, and minimize the release of stress hormones, ultimately improving meat quality. Before slaughter, pigs must be stunned to ensure a humane and painless process. Two common methods are used: CO2 gas stunning and electrical stunning. Among these, CO2 stunning is more widely adopted in modern plants. For CO2 stunning, pigs are placed inside a sealed chamber where carbon dioxide is pumped in at a concentration of 80 to 90%. Within 10 to 30 seconds, they lose consciousness. In smaller processing facilities, especially in China, the process may differ slightly. The pigs are taken directly into the bleeding machine. Then the process will look like this. Have you ever been to a slaughterhouse? Share your experience in the comments below. Once fully unconscious, the pigs are transferred via conveyor belts to the bleeding area. After the cut is made, pigs are hung upside down for 3 to 5 minutes, ensuring that most of the blood is removed efficiently. Once bleeding is complete, the pigs move to the dehairing stage. First, they are dipped in hot water 136 to 144 degrees for 4 to 6 minutes. This opens up hair follicles, making the hair easier to remove. Next, the pigs enter an automatic dehairing machine, where rotating rollers with soft rubber blades rub against the body, stripping away hair as the pigs tumble through the system. To remove any remaining fine hairs, the carcasses pass through a scalding flame, which also sterilizes the skin, ensuring cleanliness before the next stage. Next, the pigs go through the evisceration process, where internal organs are removed. In automated facilities, robotic arms equipped with razor-sharp circular blades make a precise incision along the pig's abdomen. A mechanical clamp system then gently extracts the entire set of internal organs without rupturing the intestines, ensuring the highest hygiene standards. At this stage, only the meat remains, and the pigs are split in half using high-powered cutting machines before moving along the conveyor belt. Automated saws equipped with laser-guided blades make ultra-precise cuts, separating lean meat, fat, and bones with remarkable accuracy. These high-speed machines can process hundreds of pigs per hour, delivering uniform cuts while minimizing waste. After a thorough quality inspection, the finest meat cuts are transferred to cold storage at temperatures between 0.4 degrees Fahrenheit to -7.6 degrees to preserve freshness until further processing. And now the real culinary magic begins. Watch as fresh, premium cuts of meat transform into irresistibly juicy, mouth-watering sausages. The leanest and most cohesive cuts of pork are carefully selected, along with hand-trimmed pork fat, to prepare for the sausage-making process. The pork fat is also manually filtered and added to the mixture to balance the fat ratio, ensuring the sausages remain tender, juicy, and packed with flavor when cooked. After trimming, the meat is fed into a high-capacity industrial grinder that can process up to 2 tons of pork per hour. This machine rapidly grinds the meat while maintaining its texture and freshness. First, the meat goes through a coarse grinding stage, where razor-sharp stainless steel blades chop it into evenly sized pieces before moving to the next step. Then, the meat is further refined in a high-speed grinder, spinning at 3,000 to 5,000 RPM, creating a smoother and more elastic consistency. At this stage, the hand-trimmed pork fat is added, enhancing the sausage's rich, juicy texture. The finely ground meat mixture is lightly chilled to maintain freshness before being transferred into a vacuum mixer, a crucial piece of equipment that evenly blends ingredients while preserving texture and quality. Inside the machine, high-speed paddles knead and press the mixture, ensuring the seasoning deeply infuses every fiber of the meat. Spices such as salt, pepper, sugar, emulsifiers to enhance binding, preservatives to extend shelf life, and natural flavor enhancers, including the hand-selected pork fat, are added, creating the distinctive taste of each sausage. Egg yolks play a crucial role in increasing the richness and binding capacity of the mixture. The eggs are processed through an automatic egg-breaking machine, where the shells are cracked and the yolks are separated from the whites using a centrifugal system. Only yolks that meet strict standards for consistency, color, and freshness are selected and automatically injected into the meat mixture. The vacuum mixer can process anywhere from hundreds of kilograms to several tons of mixture per hour, depending on production scale. Thanks to this technology, the meat mixture achieves an ultra-smooth texture and perfect binding, ensuring that the sausages maintain their uniform consistency after processing. Once all ingredients are thoroughly blended, the mixture is ready for casing. Sausage casings come in two main types: natural casings made from animal intestines and artificial casings made from collagen or cellulose. Once prepared, the casings are fed into a sausage stuffing machine, where the meat mixture is pumped in under stable pressure to prevent air pockets and ensure the sausages have an even, firm texture. Next, an automated twisting machine precisely divides the sausages into equal portions by twisting the casings at fixed intervals, creating uniform and compact sausages. For some handcrafted or premium sausage lines, the process relies on the expertise and skilled hands of experienced butchers, turning each batch of sausages into a true culinary masterpiece. They use traditional hand-twisting techniques, precisely measuring each section to ensure the perfect firmness without tearing the casing. This method allows for greater flexibility in size, which is especially important for fresh or traditionally made sausages. Sausages can be cooked using either steaming or smoking, depending on the product type. For smoked sausages, they are hung on stainless steel or wooden racks and placed inside a smoking chamber, where natural wood smoke, often from oak or hardwood sawdust, is generated at 122 to 167 degrees. This process enhances their deep color and imparts a signature smoky aroma. Can you already smell the rich, savory aroma of freshly made sausages filling the air? After cooking, the sausages must be quickly cooled to stabilize their structure. This is typically done using cold water baths or mist cooling systems to rapidly lower their temperature. Next, they are transferred to an air drying chamber, where cool air removes excess moisture, improving texture and extending shelf life. After inspection, the sausages move along a modern production line to the packaging area. Here, robots efficiently arrange the sausages into boxes at a speed of 120 packs per minute, ensuring precision and consistency. Finally, the packaged products are stored in cold storage at 19 degrees Celsius and transported using a specialized cold chain distribution system at 2 to 4 degrees Celsius to supermarkets, grocery stores, or exported to over 50 international markets. After about 28 days, the chicks begin to hatch, emitting soft peeping sounds from within the shells, marking the arrival of new life as each chick gradually breaks free and enters the world. After hatching, the chicks are placed into sturdy trays and transported onto a conveyor belt. At this stage, the automated system carefully moves each chick toward a specialized machine designed to remove leftover eggshell fragments. In the past, this process was done manually, taking 10 to 15 minutes per chick. But today, thanks to automation, hundreds of chicks can be cleaned in just 1 to 2 minutes, significantly faster and more efficient, while maintaining safety standards. Once freed from their cumbersome shells, the chicks are quickly carried by conveyor to the next stage, gender sorting. Here, trained staff manually examine each chick's feather color, body size, and other features to distinguish males from females. After sorting, the chicks follow separate conveyor lines, marking the start of different journeys. The mini turkey ladies are prioritized for the next stages, as they're more suitable for meat and egg production. Meanwhile, male chicks that don't meet production standards, typically due to small size or unsuitability for meat yield, are separated and sent to the byproduct processing system. In this area, they are fed into a specialized grinder that turns them into a protein-rich paste. As for the selected females, they continue on the conveyor toward the vaccination stage. Workers place each chick in the correct position on the system, and the automated equipment delivers accurate injections in seconds. These vaccines protect the chicks from common diseases such as infections, enteritis, neurological disorders, avian flu, and E. coli. After the initial processing steps are completed, the turkey poults are placed into multi-tiered plastic trays with ventilation holes to ensure proper airflow and prevent suffocation. These trays are then loaded into climate-controlled transport vehicles, where the temperature is maintained at around 32 to 35 degrees Celsius, ideal for the sensitive body temperature of newly hatched turkeys. From there, the poults are transported to satellite farms to begin the grow-out phase. Unlike adult turkeys, housing for turkey poults requires much more careful preparation. Before the chicks are brought in, workers cover the floor with a layer of wood shavings or dry straw to retain warmth and absorb moisture, both critical in the first few days. Then each tray of poults is gently placed onto the bedding, helping them adjust smoothly to their new environment without stress. Turkey poults can take up to 2 to 3 days to learn how to eat and drink on their own, unlike other poultry species that are quicker and more independent. To support them, the initial feed consists of concentrated, protein-rich pellets that are easy to digest and placed directly on the floor. Fresh water is always available in shallow trays to prevent dehydration. In just 1 week, a single poult can gain over 400 to 500 grams, with growth rates during the first month being nearly 1.8 times faster than that of conventional broiler chickens. This rapid development quickly makes the once spacious housing feel cramped. Even as they double or triple in size, the poults continue to live in groups until they reach full maturity. By around 2 months of age, turkeys begin to show their distinctive features. Smooth white feathers, nearly bare necks, and eyes that sparkle like tiny crystals, signaling the start of a new growth phase. And finally, the moment every poultry farmer waits for has arrived. When the turkeys have fully matured, reaching weights of 12 to 20 kilograms each, and the barns begin to feel overcrowded, they enter the harvesting phase. Typically, turkeys are caught at night, a time when they are less active and have slower reflexes, which helps reduce stress across the flock. Workers carefully walk through the barns, using their hands or specialized tools to catch each large turkey, then place them into dedicated transport crates, each holding about 4 to 6 birds, depending on their weight. Once the crates are filled, they are loaded onto specially designed trucks, equipped with ventilation systems and anti-slip flooring to ensure a safe and stable journey. When the trucks arrive at the processing plant, the turkey crates are carefully unloaded and quickly transferred to the receiving area. Here, each turkey is weighed and undergoes a basic health check, with key indicators such as weight and condition being recorded, marking the first step in the plant's quality control process. Throughout this stage, a specialized blue lighting system is used. This calming light helps reduce stress and keeps the turkeys in a stable state after the long transport journey. Next, the system tilts the crates, causing the turkeys to gently slide into the processing area. Here, workers manually lift each turkey into the handling system. Once the bird is rendered unconscious, it is immersed in a hot water tank. The high temperature of the water helps loosen the feathers, making the defeathering process faster and easier. The turkeys are then transferred to specialized machines designed to remove feathers. These defeathering machines are equipped with soft rubber rollers that gently rub against the skin, separating feathers without damaging or scratching the meat's surface. The turkey's legs are removed by an automated blade system operating at near blink-of-an-eye speed. As each bird passes through, the blade drops and delivers a clean, decisive cut in less than a second. The legs fall straight into a collection trough, completely separated from the body, moving forward on the conveyor. The turkey's body moves to the internal processing station. Here, an automated system creates a precise opening, followed by a specialized suction mechanism that gently collects internal components such as the liver, heart, and intestines. These parts are then directed onto a lower conveyor belt, kept separate from the main body, and sent to a dedicated byproduct processing line. In a separate area, specialists analyze chemical samples such as hydrogen peroxide, peracetic acid, or chlorine-based compounds before use. These substances help clean and brighten the turkey's skin. Although the process remains controversial, no scientific study has definitively confirmed any specific health risks. What's your take on this? The turkeys are then moved by conveyor to pre-mixed chemical baths. During soaking, an aeration system keeps the solution circulating to ensure even distribution and effective whitening across the skin surface. After being soaked in the chemical solution, the turkeys return to the familiar conveyor belt to continue the process. First, they pass through a clean water rinsing system that removes any remaining chemicals from the skin. After rinsing, the turkeys are transferred to a high-speed drying line, approximately 50 meters long. They are dried using hot air to remove any remaining moisture on the skin. In addition to rapid drying through heated airflow, the turkeys are rotated at high speed to accelerate the process while minimizing exposure to the external environment. The drying system is equipped with multiple powerful fans that ensure even heat distribution across the entire body of each turkey. After drying, the turkeys pass through an optical sorting system equipped with high-speed cameras capable of scanning up to 9,000 birds per hour. The system analyzes every detail on the surface of the skin, from bruises and scratches to uneven coloration. Image processing algorithms identify any defects and trigger mechanical arms to divert substandard birds onto a separate conveyor. Next, the turkey bodies are secured and moved through an automated wing cutting station. The system uses sensors to precisely locate the joint between the wing and the body, then sharp blades descend to separate each wing within seconds. The wings are collected on a conveyor belt below and transferred to a separate processing stage. The remaining meat, excluding the legs and wings, is sent to another processing station through the breast cutting machine. Here, sharp blades glide swiftly and precisely to separate the thick, tender breast meat from the carcass. If the wings and breast are the easy cuts, then the turkey thigh is a true mechanical challenge. The thigh joint, where the thick muscle meets the pelvic bone, doesn't always sit in a perfect position. That's why the thigh separation system uses curved blades and pressure sensors, not just to cut, but to slip precisely into the natural breakpoint of the joint. Now, everything moves into the final stage, the packaging line. Remember the internal organs we separated earlier, where speed and precision approach perfection? Breast meat, liver, heart, thighs, all cleaned and sorted, roll steadily along the automated conveyors toward high-accuracy electronic scales that measure each portion down to the gram. Next, tray sealing and vacuum packing machines take over, creating clean, uniform, retail-ready products. Each pack is labeled not only with the production date, but also a QR code that traces the entire journey, from farm to table. Every minute, hundreds of portions are inspected, sealed, and sent straight into cold storage, ready for shipment. From industrial farms to fully automated processing lines, the journey of the turkey is a snapshot of the modern global food supply chain, where technology, logistics, and appetite converge. And next time you bite into a turkey sausage or enjoy a perfectly roasted holiday bird, remember, behind that flavor lies a massive, evolving system built for one purpose: delivering clean, safe, and convenient food to millions of families around the world.